Hi guys, this is part one of Hooke's Law, setting ourselves up. So I'm going to give you a little bit of room to come up with your own ideas here on how to do the experiment, but we have a certain bits of equipment, so we're going to use that as a starting point. So for any experiment, I'd expect you to come up with an aim, and I'm going to challenge you to find the stiffness of the spring that I've used in the experiment, which you're going to watch shortly in part two of this video. So find K. Okay, so your job's to find K. You're going to have to use a formula for that. I'm going to let you go through your notes to find it. And our method that we're going to use is we're going to use the Hooke's Law apparatus, which is a retort stand. And because I'm going to show you some good habits, I'll use a ruler. And our retort stand with a base and a hanger, and we're going to put our spring, okay, and then behind the spring we're going to put a ruler. So in this case, so we're going to mark off the bottom of the spring, and I'm going to draw a ruler in, and we're going to take markings along the ruler. So our ruler will sit next to the spring, and we're going to add on our masses one at a time onto our mass hanger. Now we have a couple of choices here. We could either take our measurements from the bottom of the spring, from here, or we could take it from the bottom of the mass hanger. It doesn't matter where you take the measurements from, as long as you take it from the same place every time. And what we want to do is measure the distance that the spring is being stretched each time. So the apparatus I'm going to use is actually going to start at 0, but you might end up starting at 7, for example. And then all you're needing to do is measure the distance between each extension. So as we add on the masses, so we're going to have masses of 10 grams, and we're going to go up to 90 grams, but of course they're not forces. We're applying a force to the spring, so we need to times our by something to do with gravity if we want to increase to get a force from a mass. I'll leave that for you to find out. So that's our method. It's quite straightforward. In your results section, am I still in shot here? Yep, lovely. So in our results section, all I need you to do is collect a small table of information. I'm going to show you, I'm going to go through the practical. You can write down the information as you go. And in the table, I'm going to be looking for this information. I would like on the y-axis, the force, that will be in newtons, versus the extension, x, and that will be in meters, please. Okay, now you could do this in millimeters, but it wouldn't give you an accurate line. So we'd like to do something that's quite realistic for our spring. And hopefully when you plot your line, it's going to give you some marks that look something like so. You can draw a line of best fit in, and a little challenge for you in your conclusion. Some questions I have for you. 1, what was K? Because that's our aim to find out. What formula did you use? Now I should, if I was looking in your books, see the formula up in our method. So I'll add in an extra section here. So the formula is Hooke's Law equation, and you'll have to rearrange it for K. So K will equal something. I'll leave that for you. And so at this stage, this would be a good conclusion, a good result to this experiment. But a little bit of if you want to take this a little bit further, why does the line not go through the origin. Okay, so why would the line of best fit not go through the origin? So that is our Hooke saw experiment that you would have been doing in class. I will set you up with the video of me doing the experiment so you can get the data from that. You can produce your own Hooke's law experiment written out in your books, and you've now completed Hooke's law. Good luck.